Okay, in this video we're going to talk about superposition. Now, superposition is an important feature of the waves topic, mostly because it features what happens when waves combine together to form an overall wave as a result of the two of them. So superposition occurs when you superpose one wave upon another and they join together. So there's two types of superposition that can occur. That's constructive and destructive. So constructive and destructive. Now, those two types are dependent on the orientations of the wave at the point in which they're interacting. Now, that interaction occurs through the process of what I like to call vector addition of the displacements of the oscillations. So, superposition happens when we have vector addition of displacements. Okay, vector addition of the displacements to give a resultant displacement for the new created wave. Okay, now I'm going to show you an animation very shortly to help you get your head around this and understand what superposition is. But you just need to be aware of these terms and the fact that it occurs by vector addition of displacement. If you have those terms down in your notes, it's very, very important. And you want to draw some pictures in your notes to help you understand what's coming up. And I'll draw some pictures as well shortly in the meantime. But let's have a look at our first animation then. So this is our first animation. So this, what we've got here is, we've got two waves. We've got a wave here, we've got a wave here. Okay, very simple situation here. And one wave is going to be travelling in this direction, this wave is going to be travelling in this direction. And they are going to superpose one upon the other. And we'll watch what happens when that happens. So this will keep going, and it will keep going backwards and forwards, and we'll just talk over it. So you can hopefully nicely see there that because the waves are interacting with each other, they are superposing upon each other. At any point in time, they vector add their displacements. And I'm going to see if I can pause this at a very specific point here in a second. So there we go. I've done my best to pause that at a very useful position. This is pretty much a maximum amplitude. This is what we get as a result of that wave, those waves joining together at that point. You can see the blue and the red wave, they're pretty much right on top of each other. You'll notice that the displacement at this point adds to the displacement at this point for the red one and blue one, and as a result, we get double the displacement, which is what we'd expect. So we get double the displacement of one of the other. Notice what happens when I reduce the amplitude of one of those waves. So I'm reducing that now. So what you can see quite clearly from this picture is that we've got a superposition of a wave with an amplitude of 1 and a wave with an amplitude of 2. And as a result of that, I get a wave with an amplitude of 3 given out. And I'm going to just set this back because I want to show you a different situation here in a second. See if I can pause it. Right. Fantastic, yeah, lovely. Right, okay, so this is another situation that you need to be aware of. So look at how these waves are interacting at this position. You can see here that we've got both waves' displacement here is approximately, well, that's 1 and a bit. So what we've got is 2, nearly 4 up the top there. And so the vector addition continues onwards and onwards and onwards. Okay, so let's change it just slightly. Pause it. There we go. So this is what we like to call as constructive interference, because the vector addition is that they act in the same direction, they add together and they create a bigger wave. So what happens if I have a wave in a different orientation? So say, for example, I have something like this. So I've got this wave, which is a negative amplitude now, approaching one with a positive amplitude. And we'll see what happens. Okay, watch very carefully. And in a second I'm going to stop this, and we're going to have a look at this situation in more detail. So what we've got here is a situation where we've got destructive interference, and I've paused that almost perfectly there. So you can see where the blue wave was and where the red wave was. The combination of those two displacements is that they cancel each other out, and as a result we've got a zero amplitude at that point. And that is the same for every position on this wave. Look at this position here, that's got a displacement of 1, that's got a displacement of 1, they cancel out. Displacement of 2, displacement of 2, they cancel each other out. So this cancelling effect is destructive interference. And we can observe exactly the same thing we observed with the other one. If I reduce the height of one of the waves, what you'll notice, okay, when they interact in the same position, so this time we have a amplitude of 2 interfering with a negative amplitude of 3, and so the resultant is that I get a small negative resultant amplitude, a resultant displacement all the way along as a result of it. So let's press play and watch that in action. Okay, so that is superposition in its simplistic forms. Vector addition of displacements at any point along the wave give a new resultant wave. We get constructive and we get destructive interference depending on the relationship between the two waves at any one point in time and what their relative displacements are. So let's look at a more overarching kind of animation that shows us everything that's going on here. So what you can quite nicely see is I've got one entire wave here and I've got a second wave here. And these two are combining to create the wave at the bottom. So what we can see here is that we've got a matching up of a positive amplitude with a positive amplitude, and as a result we're getting a overall double the size amplitude. You'll notice the amplitude is from the midline, so we have an amplitude of 1 here, an amplitude of 1 here, so that means we've got an amplitude of 2 when they interact in that position. Obviously the rest of the displacements follow in line when the waves are coherent in that way. So what we have here is a situation where one wave is moving in this direction, one wave is moving in that direction. And you'll see what happens to the resultant as a result of that interaction. So you'll see here that you can see that where we're getting the constructive interference matches where the two amplitudes are matching, and we get destructive interference where the peak and the trough match up. And we'll see if we can pause it at that point as well. Not quite. That's as close as I'm probably going to get it. So you can see here that where my max amplitude meets up with my max negative amplitude on the red wave, we get a cancelling effect. Obviously I've not paused that exactly on the right position, so there's a little bit of residual there, but the idea is there that we get destructive interference in this circumstance here. So that is all about superposition and interference. Now we're going to look in the next video at interference and how it can be used to observe and measure the wavelength of specific sources of waves. Okay?